Hi everybody. Now I'm gonna use the Excel for showing you how it makes your life easier if you use Excel for the regression line. So here's the same example, 7 online stores, and this is the e-commerce monthly sale, and this is the advertisement that they spend money on that. And now we want to build our table, which I was telling you earlier. So for I just copy paste all of this. I'm gonna do that again, copy here then paste them here. Actually, you know what? I'm gonna clear the content here and make it again everything from scratch for you. So Y, I'm gonna copy this, paste it here, and then X, copy this, paste it here, and then X square, I'm gonna zoom it for you. For the X square, you just type equal to, you choose X, and then hold Shift and 6 gives you that. Then I want 2 because it's a square. So I have that. So if I come all the way down here on the corner and then as soon as you see this black plus, drag it down. You have all the information that you need. Now here, I would say y multiply by x, enter, and I'm gonna drag it down. So here is the summation. I just say sum and then choose the data. Sum, choose the data, sum, choose the data. Remember, we need the average of x and y because we need it for the calculating a, remember later. So average of y, average of x. And now I need to calculate SSXY. So in order to calculate the SSXY, remember the formula. The formula was summation of all the y's minus summation of all the x and y's, which is this number, minus open the big parentheses and then open the small parentheses, summation of all the y's multiplied by all the x's divided by 7 because I had 7 observations and then close the big parentheses. So that is SSXY. And then for SSXX, I have summation of all the x squares minus, open the big parentheses, x, summation of all the x's, a square of that, divided by 7, close the parentheses, enter. And then for calculating b, I have SSXY divided by SSXX. And then for calculating a, I have average of y's minus average of the x's multiplied by b. So that is my a. And now I can write the equation here. Y is equal to 125.83 plus 171.47 multiplied by x. And then in order to have the scatter plot, you can easily choose all of this data, insert, you see this, a scatter plot. This is a scatter plot. And then I can choose any of these dots, right click on that, add the trend line, always choose automatically linear for you, you can close that. So you see, this trend line, the function for this trend line that we had here is here. So see, I right click on that, add the trend line, automatically choose the linear for me, which I need. And these dots is exactly this line that we produced, right? So this is the manually calculating the regression. So now if I want to use the actually create the regression by having the Excel, I go to data, data analysis, find the regression here, here we go. And it says, what is your y, what is your x? Remember, x has impact on y. So in this case, advertising has impact on sales. So x is my online advertisement and y is my monthly e-commerce sale. So I would choose my y, which is monthly e-commerce sale. Actually, I'm not gonna choose the label, so I just choose a number and then input x Because I didn't choose a label, I don't hit the label here. Confidence level, if the question says confidence level is 95% or significant level is 5%, we put this here. So automatically always choose for us 95%. If it wasn't automatically, we can click on that and manually change this. And then you don't need to hit any of these residual checkbox. You don't need to do that. And then it says, where do you want to have your output? So I would say I want to have the output in the new worksheet. Okay, producing it here. So before checking any of this number here, I'm going to right click on that and then format cell just to decimal. Then I'm going to drag them a little bit here so I can see everything clearly. So here, the very first intercept, this number is my A. Remember, we were calculating that is my A. And then the second coefficient for variable X is my B. I'm gonna show different colors. So this is my A, this is my B. And something that I can check is I can see the R square here. If this number is between 0 to 1. If this number is closer to the 1, that means the model is a good model, is reliable to check the result and say, okay, this is a good thing to check. So this is, the model is 96% or 0.96 between 0 to 1 is closer to 1. So this model is a good model. I'm going to color that. It's a good model because it's 96, right? But if it was very low, like 0.20 or 0.15 or less than that, was not a good model. So we cannot rely on the result of that. And then here, we should check the p-value. We should check the p-value of the second one, not the first one, second one, right? So the p-value, I'm going to show you the different color, is 0.00, which is smaller than the significant value, which was 0.05. So I should reject the null hypothesis that was saying that X doesn't have any impact on Y, because if I reject that, that means X has impact on Y, right? So usually I give you the data and I ask you to create a regression or test the regression and also create a regression line. So in order to create a regression line, you just build this table and then you would say easily y is equal to your A was 125.83, the first one, and then your B was 171, second one, 47, multiplied by X. So this is your regression line. I'm going to highlight that. This is your regression line that you built. Okay. And then for here, you should just say reject the null because 0.00 is smaller than 0.05. Simple as that. And that's all you need for the regression. I would give you more example and more video related to that, so you feel more comfortable to work on this data. If you have any question, don't forget to ask.